I'm gonna do all the odd number problems, and the evens are kind of similar to, to the odds. So, okay. So first, get this. Okay, first thing, let's look at all these derivatives of these different inverse trig functions. So, so kind of this first one here. So you have inverse sine, inverse cosine, inverse tan, inverse cotan. Notice inverse sine and inverse cosine are almost the same. The only difference is inverse cosine has a negative. But besides that, they're exactly the same. Okay, just this negative is only the only thing that's different. And then inverse derivative for inverse tan and derivative for inverse cotan are the exact same thing, same except for a negative. So just like with regular trig functions, the cos, anything started with a co or a c, ends up being negative. So, okay, and then what this is this idea of like putting a u in here. So this is just saying, and it says it right here, u is any function of x. So this u could be an x squared. This u could be an e to the x, or an ln x, or this could be another trig function. This could be a tangent x. It could be an x squared minus 5. Could be, this u could be anything. So what this, and you can kind of look at some of the problems down here, right? In this case, u is down here is x cubed, just the thing that is inside the inverse trig function. But so what this derivative rule is saying, and it's got the kind of chain rule already in it. So this is saying whatever is inside the inverse trig function, and inside the inverse sine, you take the derivative, and that's going to be the numerator of some fraction. And then in the denominator, do the square root of 1 minus this exact thing squared. So it's kind of similar to ln's, where you just take the derivative goes on top and then rewrite it in the bottom, but just have some other stuff with it. And that's kind of the same with all these, even for tan, whatever's inside inverse tan, take the derivative and divide it by 1 plus the thing inside tan squared. Okay, so let's see how it works for when we're actually doing some problems. Okay, so here I'm gonna bring this down. Okay, so this will be, the first couple are kind of dealing with the inverse sine. So we'll bring that down for inverse sine for these first two. Okay, so according to the rule, whatever's on the inside, take the derivative of that goes in the top of some fraction, and then 1 minus the thing inside, the square root of 1 minus the thing inside sine inverse squared goes in the bottom. Okay, so y prime. Okay, so it's going to be a fraction. Okay, the derivative of this, derivative of that goes on top. So derivative x cubed is 3x squared. And the bottom is square root of 1 minus, and then just rewrite this squared. So x cubed squared is, I'll write it kind of like that, x cubed squared. Okay, so notice, right? This exact thing went here in the bottom, got squared in the bottom, and then the derivative of this went on the top, and that's it. So if you had to simplify it, it would look something like that. Okay, here, sorry. Okay. Okay, so I'll let you do number 2 on your own for homework. Okay, so next ones are inverse cosines. Let's grab that. Okay. So we're going to take derivative of this one. You see right away it's going to be a fraction. And it's going to be a negative fraction, so we'll do a negative fraction. Okay, this rule says whatever the inside is, right, whatever this inside part is, take the derivative, put that on top, so the derivative of x plus 5 is just 1. Okay, and then whatever is inside here, just do square root of 1 minus that squared. This will be 1 minus x plus 5 squared. Okay, and that's it. Okay, next one is inverse tam. Let's grab that. Okay, same idea, a little different, but no square root for this one. So inverse tam, whatever's inside of inverse tan, take the derivative of that, put that on top, divide that by 1 plus this thing squared. Okay, so f prime, we're going to have a fraction. The derivative of this thing goes on top, so that negative 1 will go to 0 when you take derivative, and derivative of 5x squared is 10x. And then do 1 plus that thing squared. Doesn't matter what it is, just square it. That's it. Okay, next one is cotam. So this one's negative. Negative fraction. Okay, whatever's on the inside, take the derivative that goes on top, and then just rewrite it in the bottom, 1 plus this thing squared. Okay, so derivative of x to the 10th, 10x to the 9th. Okay, and then 1 plus, and then all we're doing is squaring this thing. And so x to the 10th squared is x to the 20th. Okay, and then the last one, just seeing how you might have these inverse trig functions in product or quotient rule. Number 10 is a quotient rule, but number 9 is a product rule. So we'll just have to do a product rule. So we'll do derivative. Maybe I'll start out doing the derivative of this and then timesing it by this. So derivative of x squared is 2x, and then times the second thing, and then plus the first thing, x squared, times derivative of sine x. So right when you're taking derivative of a inverse trig function, write a fraction, just like you do with ln. Okay, and then so now we're taking derivative of sine inverse, and that'll be this fraction here. So take derivative of the inside and divide it by the inside squared, or sorry, square root 1 minus the inside squared. So x cubed squared is x to the 6th. And that's it. Here we might clean this up. Just there's not really much you can do. We'll rewrite that first term. And then, we could just kind of multiply these. That'll be 3x to the 5th. Okay, and that's probably most simplified. Okay, so, you see just each one of these has their own rule. They're all pretty similar, right? The answers to all these are fractions. Some of them have square roots, some don't. Some are negative, some aren't. But you can see for each one, all you're doing is taking the derivative, putting it in the top, and then rewriting it somehow in the bottom, either, square root of 1 minus that thing squared, or 1 plus that thing squared. And that's it for each of these. Okay, so the rest of these, the evens, will be for homework.